Okay, chapter 2 means to an end. In this particular chapter, we're going to talk about some of the basic statistics that you can utilize to understand a data set better and have a better knowledge of what to conclude from the data set. What's interesting about this, and this is where the picture kind of comes in, is for some data sets, there's only one real way to look at it. Just as, I don't know if you're familiar with this, but there's really only one way to get to Vegas, especially from a major city like Los Angeles. There's only one way you can go. So a lot of this will be revealed when you look at the initial statistics, when you look at the things like means and median, mode, and range. This will reveal more about this, the data set itself, just from a first cursory glance. Let's start with some key terms for this chapter. Your textbook describes three main ways of looking at data with initial data sets, and they describe these as measures of central tendency. I would make sure to know that term because it encompasses pretty much all three of these special key terms that we're going to talk about. Measures of central tendency. It's also sometimes referred to as averages. I don't really want to focus on that term just because I think people find it confusing. And actually, in fact, I don't want you to use the term average at all for this course because, once again, as I said, it tends to confuse people. When you mean average, when you say the word average, what we'll be referring to that as in this textbook is the mean. And the mean is simply the average, as it were, but it's all of the data points added together and then divided by the total number of data points. And what this allows us to see is kind of where the data falls altogether. It's really actually not as helpful as you might have been taught in previous math classes. In statistics, we tend to use it less than we tend to use the median. The reason for this is the mean can be more easily influenced by unusual pieces of data, which we'll talk about further in this chapter. The median literally is the middle point in the data. So if you've got, say, 51 data points, then the 26th is going to be the median. But this only works when they're in order. I'd like for you to think of it as kind of the center point of the data. This tends to be more useful, and we'll talk more about this in a second here as well. And the third one is the mode. The mode, very simply, is the most common data point or most frequent data point in the data set. So if you were to look at shoe size in men, it might be like an 11, for example, would be the mode, the most common shoe size. So we're going to be using these terms quite a bit, and we'll elaborate on them a little bit further as we move through the chapter. So we'll start with a mean, and I don't know why. I'm a very picture-oriented person. I think of like a mean little puppy. And you get in the bottom right here. I would never really think of a mean puppy, but that one in the bottom right I think looks pretty mean. The mean is going to be what's referred to as the most common type of average, a most common type of measure of central tendency. When people discuss data, even people that don't know data very well, they'll typically refer to the mean or the average. They'll say, well, the average income is blah, 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 or the average age is yada, yada, yada. In this case, it's useful, but to a certain extent. As we'll talk about in a couple slides here, is the mean is somewhat useful, but can also be deceptive. The median is a preferable way to go, and that's what we utilize more often when we're talking about statistics. As I said on the previous slide, it's calculated by adding all the values up and then divided by the total number of values. Something that you might want to start at this point in your notes is the relevant letters that correspond to different terms. So for example, for mean, we tend to use a capital M that is italicized. That's typically the symbol utilized for mean. So when you see a statistical text or a journal article, it'll have capital M italics equals 83.6 or what have you to symbolize the mean. Lowercase n italicized is typically the symbol for sample size. We'll use the term sample. Actually, we've already used it in the previous chapter, but we'll continue to use it throughout this course as well. So literally the total values added up divided by lowercase n gives you capital M, as it were, the mean. Just a quick example of how to calculate mean. In this case, you have three different stores here, the Landon Park store, the Williamsburg store, and the downtown store, all with their own number of annual customers. What you'd simply do is add all three of those number of annual customers together and then divide by 3, in this case because your sample size, or n, equals 3. And then when you do this division, your mean is going to be 2,416. And this is going to give you a relative idea of how the data comes together. When you're reading articles in a newspaper or online or what have you, usually they'll report the mean. And as I said, it is useful to a certain extent, barring something unforeseen, which we'll talk about in just a moment. So always kind of take the mean with a grain of salt. Now, your textbook talks about something that you might not be as familiar with. It's referred to as weighted mean. In this case, as we'll see on the next slide, this is simply when we're actually have multiple occurrences of the same value in a data set. So what it's going to do, it's going to be a type of calculation of mean, but it's going to be a slight variation on that. It's calculated literally by value times frequency divided by total frequency. And we'll look at another example of this on the next slide. What might be something that's more useful to you and more to your experience is if you were to calculate your grade in terms of weight. So for example, I've got on the bottom here a situation where you've got 2 exams, quizzes, homework, and term paper, all of which have a designated weight for the overall class that adds up to 100% of the overall class. In this case, what you can do is multiply the weight of the actual item by the score you received to get your weighted score. And what you can do is simply add these numbers together to give you yourself the actual grade you've earned out of 100% for the course. I have a lot of students who email me all the time saying, Dr. Joe, what's my grade in the course? And I would refer to them to this sort of strategy for figuring out their grade, in that this provides you the exact number and kind of gives you an idea of where you stand. If there's only a few things that have been graded, you can say, okay, well, I still have an opportunity to get this many more points, and that could put me at this particular grade. Students will often ask, well, can I still earn an A in the class? And I will answer the question, of course, but I also refer them to how to calculate it, which would be the case here. So this is actually a very, very useful tool. In fact, Blackboard can do this for you in your own gradebook. But it can be useful in trying to figure out where you are in a course and how much more points you have to earn in order to get the grade you desire, hopefully an A. As I said on the previous slide, essentially what we're doing here is taking a certain value, for example, 97. If it occurred 4 times, what we're doing is doing 97 times 4 and getting the value times frequency score. This might be something that I would utilize, for example, when looking at the weighted mean of a class average on an exam, for example. So if there are 4 people that got a 97, 11 people that got a 94, 12 people that got a 92, so on and so forth, I could actually look at the weighted mean for the class. And what this does, in contrast to a regular mean, this actually allows you to consider how many people achieved a certain score, and that's actually weighted against the number of people who got other scores. So for example, the 60 in the class would actually carry much less weight than, for example, the 92 or the 90, in fact, because there's so much more of a frequency for those other 2 data points. So this actually can be a better reflection of actual performance that's not nearly as affected by unusual scores, in this case the 60. So a useful tool, particularly in certain contexts where the frequency of a certain number or certain numbers might be quite high. All right, so the median, I've already kind of talked it up and told you how much better it is, and it really is. As I said on a previous slide, it is literally the middle value when all values are arranged from highest to lowest or lowest to highest. It doesn't really matter which direction they're arranged. As long as they're properly arranged, lowest to highest or highest to lowest, you simply select the middle value of all of them. And as you can see, obviously, it doesn't matter which way they're arranged if you're just picking the middle one, because it's not going to have an effect, obviously. When you do this, the median will always pick out the 50% mark, in that 50% of the values will fall below and 50% of the values will fall above. This is a common misconception about mean. Mean does not necessarily do this. You could have a mean, for example, that actually cuts off at the 80% mark, which sounds crazy, but actually the math behind it is legitimate. We'll see an example of this in another slide. But with a median, by contrast, there will always be a 50% cutoff for the median. In the event where there's an even number of values, say 40, what you would do in this case is take the 2 middle values, 20 and 21, as it were, add them together, and then divide them by 2 to find a mean. So in this case, the median wouldn't actually be a given value in the data set. It would just be a designation. This divides the data set in half. Median is something that, as I said, we'll use quite a bit, and kind of, as the picture indicates, I want you to think of it like the median in a road. You most likely will have 2 lanes on one side and 2 lanes on another, or 4 lanes on one side and 4 lanes on another. It's unusual for you to have, say, 3 and 1, or 2 and 4, something like that. So there's almost always an even 50% split with the median in the road, and in statistics, there's always a 50% split with the median. So a quick demonstration of what we talked about on the previous slide, calculating the median. In this case, I've got the costs of cars here. The table on the left has 5, the table on the right has 4. For the table on the left, since they are already arranged from lowest to highest, you'll simply just select the one that is in the middle. In this case, it's the GMC Sierra Denali at $42,537. For the table on the right, since there's an even number, you would actually add the total price of the Audi A4 Avant and the Nissan 370Z Nismo and divide that by 2. So $41,266 plus $43,628. add them together, and then divide by 2. This will give you a median of 42,447. And you'll notice, too, that the numbers aren't very discrepant between the two. 42,537, 42,447. We're talking about a difference here of what, $90. So the median is actually doesn't change a great deal, will not change dramatically with the addition or subtraction of data. This is in contrast to the mean that could be dramatically changed simply by adding one more number or taking one data point away. So at this point, you're probably thinking, so why? Why would we use a median when everybody and their dog seems to use a mean? See what I did there, everybody and their dog, because it's a little mean dog. Anyway, whatever. Why would I use the median? And the question I would put before you, or actually to answer your question, is we use a median because it is not sensitive to extreme scores. And this is in large contrast to the mean. I'll show you an example of this on the next slide here. But that is what I really want you to know. We use median because it is much less sensitive to extreme scores, and thus will provide a much more accurate representation of how the data falls. It's actually not sensitive to these extreme scores. We're going to use a term called outliers. That's a term I'd love for you to know for the rest of the course. Outliers, at this point, I'll define it to you as an extreme score. That's all you need to know for the moment. We'll get a more precise definition later on in a subsequent chapter. For those of you who are just dying to know, it is a value that falls more than 3 standard deviations away from the mean, which might not mean anything yet, but that's okay. We'll work to that. But an extreme score, for example, would be if I was taking the average height of everyone in the class. The average height might turn out to be, I don't know, 5'11", right? But if Shaquille O'Neal was to join our class, his data would skew the mean. Being, I think he's like 7'3", I mean, just very, very tall indeed. His height could change our mean to where suddenly the average height of the class is 6'2". This would skew our mean higher than it actually would represent for the overall class. Whereas if we're using a median, no matter if Shaquille O'Neal is 5'11" or 7'3", his additional score would not dramatically change the median very much at all. So it's a much more accurate representation of how the data falls. Building off of what I said on the previous slide about the sensitivity here, for example, another list of cars. I'm a big car guy, so this is kind of why it's relevant. In this case, I have a list of 5 cars: 38,789, 41,266, 42,537, 43,628, and then the Nissan GTR, $84,060. Right? If we look at this, if we did a mean, added all these 5 together and divided by 5, the mean or average would be $50,000. Well, if you look at that, where that falls, 4 of the cars actually cost much less than $50,000. So it doesn't really divide the data set in half very well. However, the median is $42,000. The reason why it falls much better in the middle here is because it actually falls pretty central to most of the data points here. The Nissan GTR in this case would be the outlier. It is an extreme value. It is almost double the price of the next highest vehicle, being the Nissan 370Z. So it's actually will be skewing the mean a great deal. In this case, it skews the mean by several $1,000s and makes the data set seem like it has much higher values than it actually does. This is why the median is a much better strategy for evaluating a data set, and that it provides more accuracy in terms of how the data falls and centralizes. All right, the third of the measures of central tendencies that we'll discuss in this chapter is the mode. And this one's almost certainly the simplest. Essentially, what you're looking for is the one with the highest frequency. And I provide a little table here of different car colors: red, blue, black, and silver. You can just look at the frequencies 7, 12, 45, and 55 and know that the most frequent one is silver here. In this case, silver is the mode. And I use this as a real-life example because, in fact, in almost every country in the world, silver is the most common car color purchased. I believe it is starting to change in certain countries, but traditionally silver for the longest time now has been the most common car color, and I include a little silver smart car in the bottom right to kind of help you remember that. The reason why we look at the mode doesn't actually indicate where the data falls in a grand sense, but it will show the one with the highest frequency. So, for example, if I want to know how students are performing in class, I might look at the most common score on an exam, and that would help me decide kind of where people fall to some degree. It's not going to give me a central tendency of any way, but it'll just show the most common score on the exam. What I want to emphasize with this is the mode, the mean, and the median are all 3 useful in conjunction with each other. To really understand the central tendency of a data set, you really have to look at all 3 in addition to the range itself.